Okay, thank you. Right. Yeah. Welcome back, my dear friends. So this is the 10th day of our lectures, the series of lectures in mathematics for GATE preparation. So we have successfully completed partial differential equations also, but for the applications of partial differential equations, which are very important for all the engineers. Particularly, some students have given me in their feedback form. They have mailed me that please explain us the applications of partial differential equation, particularly wave equation and heat equation. Not only in mathematics, we are also getting these things in a core engineering like conduction of heat in mechanical fluid mechanics, so on and so forth. So actually, I wanted to finish it off day before yesterday on Saturday, but anyhow, because students have expressed their interest in that, so I am giving some more. I wish to focus more light on applications also. So the second order partial differential equations, we have seen how we solve the equations using variation of parameters method and other things. Now we'll go through one or two applications, and we have three important basic applications that we generally discuss. Not that they are the only applications. They are the most important basic applications of partial differential equations in engineering sciences. One is, the first one is, why these three things have taken is, in the classification of PDE, we have discussed that the second order partial differential equations are classified into three types depending on the structure of this A, B and C, if you remember, right? Okay. Then, yes, this is what exactly we want to study now. So, okay. The classification of second order partial differential equation, the general standard form of second order partial differential equation is axy dou square u by dou x square plus bxy dou square u by dou x dou y plus cxy dou square u by dou y square plus dxy dou u by dou x plus exy dou u by dou y plus f of u is equal to 0. Where u is a function of x and y, then this standard partial differential equation is classified into three categories. If this b square minus 4ac is less than 0, we call it an elliptic classification, elliptic category, elliptic type. And if b square minus 4ac is equal to 0, this is called parabolic type. And if b square minus 4ac greater than 0, hyperbolic type. And we have seen a couple of examples also how the nature of a given partial differential equation changes from one region to the other region. In one region it may be parabolic, in another region it may be elliptic, and maybe hyperbolic to parabolic, hyperbolic to elliptic. It may change in different regions. But if an equation is throughout the region, if it is elliptic, then we call this completely. And the best examples that we have for these things and basic engineering applications are, for the elliptic equation, the Laplace equation is a best example of second order differential equation. Laplace equation in 2 dimensions. Parabolic equations, the best example, heat equations are the basic examples. And for hyperbolic equations, this is wave equation. So, basing on this classification, for each type, one important engineering application has been mentioned, like Laplace equation, one for each type. So that's the reason why we have collected these three only. Otherwise, there are so many such examples. But in the syllabus, what we do generally is, for each type we give an example. So that way, we have picked up these three equations. Okay, right. So in that sense, one-dimensional wave equation, hyperbolic, one-dimensional heat equation, parabolic, and two-dimensional Laplace equation, elliptic equation. So let us deal with these things one by one. First two things. In GATE examination point of view, these problems are very lengthy. I accept these problems are very lengthy in GATE examinations. Even as suggest you, if there's such a problem is, then the problem is given in GATE, it's better to go to the next problem than spending a lot of time, minimum 5 minutes time on these problems. So this is my suggestion. But if there are, as I told you earlier, this single problem can be divided into smaller problems, small bits. In that case, you have to understand how those small problems can be tackled. So for that, we have to learn this. You cannot lose small bits. If it is given as a full complete problem, like a 12 marks essay question, you cannot do it. But a part of this problem can be asked as a simple bit, then you cannot afford to lose it. So we have to do it to avoid such small leakages, right? So first we will see what is one-dimensional wave equation. So this is a diagram that we generally have to understand. Let us say from OA we have a string, tightly stretched string like this. Okay, that means tightly stretched and fixed at both the ends, right? So let us say length of the string is L, fixed at O and A. So at O and A it is fixed, so that means there is no displacement at the end points. It is fixed. Let T be tension in the string constant and a large compared to the weight of the string. Why we use this condition is to avoid this gravitational, to neglect this gravitational things, stuff. We say that tension is constant and large compared to with weight. When T is large compared to weight, and weight can be neglected. Weight means mg. So gravitational thing will be neglected. That's why we use this condition. Otherwise, what happens is we have to put this gravitational acceleration also into the equation. To avoid that, a simple model, we assume that the weight of the string is very much small. And then once the string is stretched tightly like this, then hold the string, just pull it one side, or else just pluck it like this. Give it a vibration. So both ends are fixed, and then apply some force and it will start vibrate. In fact, this is the thing that is in most of the string instruments like veena, sitar, guitar, in all these music instruments. This is the concept we see actually. Every day, whatever music you hear, just this is the example. So fix the string at both the ends, then apply some force and put into vibration. This will vibrate like this. Okay, this is equilibrium position. It will vibrate like this. Okay, the displacement. First, understand the problem clearly. Solution is not difficult. String is plucked to OBA. So this is the equilibrium position string, and this is pulled to one side to B, and then a force is given to it. Displacement at any point of Y depends on X and T. This is X-axis. The displacement here is small. Here it is almost all, here it is 0. When it goes to the center point, displacement is maximum. When you go away from origin, again the displacement reduces. Finally at that point it becomes 0. So displacement is completely dependent on X. First thing. Second thing, just give it some force, it starts vibrating. It vibrates with maximum amplitude. Then what happens gradually? It comes down. So after some time, what happens? It becomes 0. Okay. So displacement at any point Y depends on X and T. So X and T are independent random variables, and Y is the displacement of the string. My dear friends, I want to just make one note of it here. See, today there has been a rain since yesterday, so there are some fluctuations in the power and also in internet. So in the middle of the class, at any point of time, if there is any technical lapses, please bear with that. And there I will stop the class. To that extent, I have asked the organizers also. They said yes for that. So I am going ahead with the caution that if there is any technical lapses like internet failure or something like that, we will not continue, and we will continue in this class. Till then, we'll go ahead. Okay. So let's come back. Then Y is a function of clearly, as I explained, is displacement and time. As the time is gradually, the vibration gradually comes down. After some time, again it becomes it comes back to its equilibrium position. So the vibration is also depending on time. So the displacement is clearly a function of x and t, and the corresponding partial differential equation, we are not going to the proofs, is given by dou square y by dou x square is equal to 1 by c square dou square y by dou t square, where c square is t by m. As I said, t is the tension mass, m is the mass. So equation 1 is called one-dimensional wave equation. So what do you understand? At the endpoints 0 and a, that means at x is equal to 0 and at x is equal to a, the displacement is 0. So y at 0t is equal to y at lt is equal to 0. So these are the two important conditions. Then initial position. So if the string is initially like this and give it a force like this, leave it, then start vibrating. That is one way. In that case, initially is at y is 0. Sometimes what happens? You pull it to one side like this, okay, then start leaving. Then leave it. Then it starts vibrating. So when it is like this, in the initial case, this has some displacement, right? So that displacement y at x is x comma 0. That means initially, that means time t. Initial means in all applications, mathematical sense, when we say t is equal initial, it means that t is equal to 0. So when t is equal to 0, y of x is equal to the displacement we call it as f of x. So because t is fixed as g of x, but you got it. So it's already vibrating like this. Okay, then I observe the string at some time. I start my clock. It is vibrating, and then see that where I start my observation is t is equal to 0. Then it has a velocity. So that velocity is dou by dou t x comma 0 is equal to g of x. So these are the conditions that we require. Because why do you need the conditions is because a second order differential equation, partial differential equation, as we discussed earlier, it will have some arbitrary constants. To eliminate the arbitrary constants, we need some conditions on the solution. So these conditions help us to evaluate the constants involved in the general solution. Of course, we don't worry about the solution pattern. Directly we'll go to the direct general solution. But a couple of observations here. If the initial displacement y at x0 is 0, that means initially there is no displacement in equilibrium position. There is no displacement like this. It is just at rest, equilibrium position. Then any point of the string will be given a initial velocity dou y by dou t at t is equal to 0 is g of x. That means in general, it need not be true always. If f of x is equal to 0 is considered, then the velocity will be given, initial velocity will be given. If the string is released from rest and initial non-zero displacement is given, then yx0 is fx is given. So if this is given, then fx will be 0. If fx is given, then gx will be assumed as, taken as, will be given as 0. These are the two important observations in general. Okay. Then, in such case, for such a vibrating string, the general solution of such a one-dimensional wave equation given by dou square u by dou x square is equal to c square dou square u by dou t square have an equation with boundary conditions. So, the equation is dou square y dou x square is equal to 1 by c square dou square y by dou t square, and the conditions are at the end points displacement is 0, initial position is f of x, and the initial velocity is g of x. Then the solution is given by y of xt is equal to sigma n running from 1 to infinity an cos n pi ct by l plus bn sin n pi ct by l into sin n pi x by L. So how we get these things is, in solution to partial differential equation, one of the very important topics that we very frequently apply in applying the solution is Fourier series. All of you might have done this Fourier series. This is a very, very important idea for partial differential equations. So here y of xt is expressed as a Fourier series in terms of Euler coefficients, where a n and b n are called Euler's coefficients. Then what is a n? A n is 2 by L integral 0 to L f of x sine n pi x by L dx, and bn is 2 by L 0 to L g of x sine n pi x by L dx. This is called half-range Fourier series of these functions fx and gx. So if you calculate this a n and b n, if fx and gx are given, calculate a and b n, put them here, this will be the general solution. Only thing is we have to evaluate the integrals. As I said earlier, if f of x is equal to 0, the initial displacement is 0, then this a n becomes 0. Then this a n becomes 0. Then the solution y of xt will be so simply in terms of bn sin n pi ct by L into sin n pi x by L. And if initial velocity is 0, that means g of x is 0, then this term goes out, becomes 0, bn will be 0. So this the solution will be in terms of only an. So y of xt is sigma an cos n pi ct by L into sin n pi x by L. So these are the two basic special conditions that we have. So fortunately, if the problem if f of x is equal to g or 0 or g of x is equal to 0 are given, one of these two things is 0, then directly you can use this formula or this formula and calculate a and you will get the. And I'm telling you, in the examination they are asking questions. I will show the whole question paper examination. Some question paper, gate papers, they have asked this question. So consider an example here. A tightly stretched string with fixed ends, x is equal to 0 and x is equal to 10 cm. That means length of the string L is given. 0 to 10 means L is 10 centimeters. From the problem we have to get all the points one by one after another. Fixed ends x is equal to 0 and x is equal to 10 centimeters is initially at a position. So initial position is given. So what is that? Initial position means this one. Y of x 0 is f of x. This is the initial position. So f of x is given. If it is released from rest from this position, rest means, what do you mean by rest? Rest means, in physical sense, velocity is 0. When velocity is reached at 0, we say it is rest. So that means here this gx is 0. So for each condition given in the problem, we have to see in mathematical sense. So gx is 0 and fx is given. If we leave from rest from this position, so from this position it is released, and that means initially the string is at this position and then it rests and it is at rest, then it is released. So y of x0 becomes y naught sin cube px by 10 and dou y by dou t, initial velocity is 0 and at the end point this y is 0, because end points the string is fixed, there is no displacement. So whenever g of x is 0, we have the solution like y of xt is equal to sigma an cos n pi ct by L into sin n pi x by L, where an is given by 2 by L integral 0 to L f of x sin n pi x by L. So this is what we have. Bn becomes 0. So yx0 is, if you put t is equal to 0, cos 0 is 1. So an cos n pi x by 10. But what is yx0? Y naught sin cube pi x by L. But sin cube theta is 3 sin theta minus sin theta by 4. We know that from trigonometry. So 1 by 4, this becomes 3 sin pi x minus sin 3 pi x. Now, if you compare this series expansion with this, what we require is an. If you compare this expansion with this, an sine pi x by 10. What is the coefficient here? Sine pi x is the first term. When do you get sine pi x here? Only when n is equal to 1. So when n is equal to 1, we get a1 sine pi x by 10. So this is 3 into y0 by 4 into sine pi x. So a1 becomes 3y0 by 4. If you compare the coefficient, a1 becomes 3y0 by 4. We don't have a2 term here because sine 3 pi x is there, because the second term will be with n. So the second term will be 0. The third term, because n is 3 here, the third term will be a3. So that will be equal to minus pi by 4. So with this, if you put this a1 and a3 in the given solution y of xt, that becomes 3y0 by 4 cos n pi ct by 10 to sine pi x by 10. a2 is 0, a3 is minus y0 by 4. a3 means n is 3. So cos 3 pi ct by 10 sine 3 pi x by 10. Okay. So if you want to verify it, what is y of x at 0? When y of x at 0 is there, what we get? This t becomes 0, cos 0 becomes 1. So 3y0 by 4 sine pi x minus y0 by 4 sine pi x. So another problem is a tightly stretched string with fixed ends x is equal to 0 and x is equal to L is initially at rest in its equilibrium position. So the string is stretched with fixed ends and is initially at rest in its equilibrium position. That means initial velocity is 0 because it is at rest, and its initial position is equilibrium position. That means fx displacement is 0. So both fx and gx are okay. It is set to vibrate by giving a velocity. It is set to vibrate by giving a velocity lambda x into L minus x. So initial velocity is lambda x into L minus x. Initial position is equilibrium position. That means fx becomes 0 and initial velocity is lambda x into L minus x. So this is the condition. In such case, y of xt is given by sigma bn sine n pi ct by L into sine n pi x by L. So bn becomes 2 by L integral 0 to L g of x into sine n pi x by L dx, where g of x is expressed as Fourier series. So what is gx? Lambda x into L minus x. So 2 lambda by L. If I put this here, bn becomes 2 lambda by L integral 0 to L Lx minus x square into sine n pi x by L. So if you integrate this, simplify the whole expression, what we get is 4 pi L cube 4 lambda L cube by n power 4 pi power 4 into c. Okay. So that becomes 1 minus 1 power n. So if you put this here, y of this in y of xt, sigma 4 lambda L cube by n power 4 pi power 4 c 1 minus 1 power n sine n pi ct by L into sine n pi x by L. So this is the solution that we get after substituting this bn in the given form. So next one is find a solution of dou square u by dou x square is equal to dou square u by dou t square. Then x lies between 0 and 1, t greater than or equal to 0, subject to the condition y of x0 is equal to sine pi x. So that means initial position is sine px in 0, 1 and initial velocity is 0. So the most general solution in this case, general is y of xt is sigma an cos n pi ct. There should be L actually, but the length of string is given as L is equal to 1, so I have not written L here, into Bn sine n pi ct into sine n pi x, because L is equal to 1. So dou 0, that means Bn becomes 0, we have seen that. So y of xt is equal to sigma an cos n pi ct into sine pi x, sin n pi x. So an is 2 by L, 0 to 1, sin pi x. The function is sin pi x. Sin pi x into sin n pi x dx. We know that 0 to 1 sin pi x is n is equal to 1. It becomes 1. It becomes here sin pi x into sin n pi x. We know that sin square pi x is 1, but sin pi x into sin n pi x is 0. So the only term we get is when n is equal to 1. So y of xt becomes, Bn is already 0, a1 is cos pi ct and sin pi x. For any other value of n, this an becomes 0. So the solution simply becomes cos pi ct into sin pi x. You can verify it. Y at x0 is cos 0 into sin pi x. Cos 0 is 1. So yx0 is sin pi x. So that's how, if you remember the general expression and then expressions for fx is equal to 0 and g of x is equal to 0, wave equations, most of the problems in wave equations can be successfully attacked and completed. Okay. Then the other important application is one-dimensional heat equation. As I said, this is the example for parabolic equation. If you want, you can check it. One-dimensional heat equation. So here the problem is, consider a homogeneous bar of uniform cross section. So consider a metal bar of uniform cross section like this. It's like a metal bar like this. You can take it like this. Okay. Laterally insulated. That means all this body is covered with the insulating material. What to ensure that the heat will not leave this surface like this. Heat cannot be dissipated along the surface. So that means it is to ensure that the streamlines of heat, they cannot go out of like this. They travel only in this direction and parallel to the end, one another like this. I have given drawn like this, see, parallel to one another like this, and they leave like this only. They come like this, or they come like this, they leave like this. They leave like this. How do you say that? If this is the cross section of this material, that means the flow lines will be going out, will be perpendicular to the end surfaces or cross sections. The heat flow streamlines will be perpendicular. This is surface like this. They come out in perpendicular, along normal direction. So they come out of this units, cross section area along the normal direction. But they can never leave the surface anywhere else. Only because material is completely insulated. Only thing is here and here they travel. They dissipate. So laterally insulated so that streamline of heat are parallel to one another like this and perpendicular to cross section. This is cross section and the streamlines come out like this. So rho with the density, S with the specific heat, and K thermal conductivity of the material. Then U of xt with the temperature at any point xt. Then one-dimensional heat equation is given by dou U by dou T is equal to C square dou square U by dou X square. Okay. C square dou square U by dou X square. Where C square is called diffusivity coefficient. C square is called diffusivity coefficient is given by C square is equal to K by rho into specific heat. So this equation is called one-dimensional heat equation. If we have a two-dimensional heat equation, you will get C square into dou square U by dou X square plus dou square U by dou Y square. So then how we solve? There are three different forms of the solution here. For different invariable separable technique, there is one expression that is equal to k square. Depending on the k square, u of xt may be a1 e power px, b1 e power minus px e power p square c square t. U of x2 is equal to a plus b2 x, and the other one is some periodic functions like this cos px and sin px into e power minus p square c square into t. Then out of the three solutions, which should be considered? That is the issue. Selection of the solution depends on given physical conditions. Of these three things, which one should be considered, which one should be neglected, that depends on the physical conditions of the problem. Now, let us say, assume a condition like as t goes to infinity, u of xt never goes to infinity. Say for example, we have a heated body. It is having some temperature. Okay, there is no source here, leave it like this. So gradually what happens? The temperature of the body comes down. As t increases, time increases, what happens? It will never go to infinity. The temperature comes down gradually. It comes back to the room temperature. So as t goes to infinity, u power xt never goes to infinity. And also it depends on t. As increasing time, the temperature gradually comes down. U of xt changes with time. So if say for example, if you consider the first one, as t goes to infinity, what happens to this term? It goes to infinity. So the temperature of the body does not go to infinity as t goes to infinity, it comes down. So this is not the actual solution. And also u of xt depends on t. But if you see the second equation, u of xt is equal to a2 plus b2x. There is no term of t, but it is not correct because temperature of the body depends on time, not independent of time. So the second one is also not a valid solution. So the solution, general solution is considered as a cos px plus b sin px into e power minus p square c square t. Clearly it's a function of x and t, and as t goes to infinity, what happens? This is e power minus t becomes 0. Becomes 1. Okay, so that way also this solution satisfies all the physical condition. As t goes to infinity, 1 by this is e power p square c square t goes to denominator goes to infinity, so the whole thing becomes 0. So that means gradually temperature comes down. That is what we how we select the solution, best suitable solution out of the three possibilities. Now steady state condition. Steady state condition is defined as like this: a state at which u of xt becomes independent of time. That means the derivative with respect to t becomes 0. Because u is not depending on t, dou u by dou t becomes 0. So the equation of one-dimensional wave equation, the heat equation under steady state conditions, it may be asked as, I am telling you repeatedly, these problems may not be asked complete problems. They can be small parts of the problems can be asked independently. So this is a very, very important question. The one-dimensional heat equation or two-dimensional heat equation under steady state conditions is given by, what happens? Dou u by dou t becomes 0. Then the equation becomes dou square u by dou x square is equal to 0. In two dimensions becomes dou square u by dou x square plus dou square u by dou y square is equal to 0. So dou u by dou t becomes 0 under steady state condition. The equation now becomes dou square u by dou x square, or u is equal, if you integrate these two times, u becomes ax plus b. So this is also one more question. Under steady state conditions, the solution of one-dimensional heat equation is u is equal to ax plus b, u is equal to at plus b, u is equal to ax plus b into e power minus n pi square p square c square t. D, option D, e power p square c square t. Maybe some wrong options. What is there? The correct answer is always 1. All others are wrong options you can say anything. So that these things can be directly given as questions, smaller parts of subparts of the problem. So this is steady state condition and its solution. So general formulation. Consider a bar of length L laterally insulated like this. The temperature at x is equal to 0 and x is equal to L. That means these two end surfaces, this surface and this surface, are maintained at T1 and T2 respectively until steady state conditions prevail. Because these two temperatures are different, so we know that a potential energy or energy always moves from high energy point to low energy point. Let us say it is 0 degrees, 100 degrees. Gradually what happens, the whole body will be, temperature will be uniformly distributed throughout the body. And then steady state conditions prevail. Then once the steady state conditions are reached, then this temperature at these two surfaces are changed to T3 and T4. So T1 temperature is adjusted to T3 and T2 is changed to T4. Once the uniformity is obtained, then we are changing the temperatures again. Now, under these conditions, what is the temperature distribution in this metal body? That is the question now. That's what we have to calculate. So the problem mainly has two parts. So whenever we conduct of heat conduction problem, heat conductive problems, the solution contains two parts: steady state solution, and the second one is unsteady state. Unsteady state or transient state. Steady state and transient state. There are two types of solutions we have to calculate for the given problem. And we add up those two things, steady state solution and transient solution, that gives the solution of the given problem. The solution, step 1. At steady state, u of xt is equal to, because when at the time of steady state conditions, u of xt becomes, it will be independent of t, that becomes ax plus b. Now use the conditions we have. At x is equal to 0, what is the temperature? T1. So put x is equal to 0 here, a into 0 plus b, that means b is equal to T1. At x is equal to what is the temperature? T2. Okay. So if you put x is equal to L, AL plus B, and B is T1, so AL plus T1, this is equal to T2. Implies that A is equal to T2 minus T1 by L. So that means your steady state solution is T2 minus T1 by L into X plus T1. This is the first step. Then what happened? Once the steady state condition is achieved, then the temperatures are changed. So T1 becomes T3 and T2 becomes T4. This is what happens. Again, after some time, the metal rod attains steady state conditions as T increases. Then U of Sxt becomes T4 minus T3 X plus T3. Just like following the same formula, because the new temperatures are now T3 and T4, this becomes T4 minus T3 by L into X plus T3. Call it as equation number 2. During the process now, first steady state achieved, then transient state begins. The beginning of the transient state, okay, now the solution during the transient state plus excess, that gives the solution, final solution. So the solution contains steady state part, that is T4 minus T3x plus T3, and unsteady part U transient, TR stands for transient state. These two parts together gives you the solution. So such that U of xt is equal to US, that means steady state solution plus transient state solution. For the process, U of 0t. So once this steady state condition is achieved, then the temperatures now, new temperatures are U of 0t is T3 and U of LT is T4. New temperatures. And what is initial temperature? That is given by, that means, so if from there if you measure now T is equal to 0, so there the temperature already whatever is having under steady state conditions, that will be your initial temperature. So that means the process is like this, you have come like this, you are getting steady state. from their new process. Now we are considering this process for which the new temperatures are T3, T4 at the end points, and the initial temperature is whatever is accumulated till now, that is US. So U of 0T is equal to T3, U of LT is equal to T4, and if you put them here, U of X is equal to 0, this becomes 0, T3 plus UTR. Okay, so that becomes UTR 0T is 0. This is UTR. T3 gets cancelled, so U3 becomes 0. Similarly, X is equal to L, T4 minus, if you put this L here, T4 minus T3 by L into L gets cancelled, T3 gets cancelled. This is T4 is equal to T3 gets cancelled, T4 plus UTR LT. That means if you cancel T4, UTR at L becomes 0. So, say the boundary conditions. Now, what is the initial condition? But at the beginning of the process, the temperature given by the previous stage steady state solution T2 minus T1 by X into L plus T1. That is already the temperature that body has acquired already throughout, is equal to this steady state at this stage, that is T4 minus T3 by L into X plus T3 into UTR X0. UTR X0. So UTR X0 is, if you send these terms to the other side, T2 minus T1 minus T4 minus T3 into X by L plus T1 minus T3. So you call this as C, this constant as C, and this as D. So UTR X0, that means the initial condition is Cx plus D, where C is like this and D is like this. So now dou by dou t, from the transient equation state, the solution is given by like this. So if you solve this equation, UTR xt is sigma an sin n pi x by L e power minus. I am doing a standard expression. I am not going to the proof. Just I have explained how I to tackle the problem. Steady state condition, from their transient state, whatever solution you have in this steady state condition, yes, that will be initial condition for the transient part. Remember that only. So UTR xt is an sin n pi x by L e power minus c square n square pi square by L square into t, and an is given by like this. So with this U of xt is T4 minus T3 by L into X plus T3 plus UTR xt. But this an, you have to be very careful with this in calculating this an. This is how we calculate the one-dimensional heat equation. So let us say a problem. A bar of length L, laterally insulated, has its ends A and B kept at 0 and 60 degrees respectively until steady state conditions prevail. Then the ends A and B are changed to 0 and 0 degrees. A is already at 0, it is maintained at 0, but B is suddenly reduced to 0 degrees. Find the temperature distribution in the rod. So first, at steady state, Ux is equal to Ax plus B. We have seen how it happens. At X is equal to L, X is equal to 0. If you put 0, U of 0 is, it is at 0 degrees. Okay, so B becomes 0. And at X is equal to L, that means other end, initially temperature at 60 degrees. So at X is equal to L, this AL plus B, B is 0. So it becomes AL is equal to 60 and A is equal to 60 by L. So your solution now becomes Ux is equal to, because B is 0, 60 into X by L, call it as 1. Now we got the steady state solution. Then the temperatures are changed to 0 and 0. Okay. So 1 becomes initial temperature for this becomes the initial temperature for the transient solution. So the transient X0 becomes this solution obtained for the steady state solution. So that becomes 60x by L. So UTR 0T, once the steady state is observed, what are the endpoints? It has become 0, it has become 0. So U0T is 0, UTR is 0. Then U of xt is equal to USX plus UTR xt. So USX is T4 minus T3 by X plus T3, that is 0, because if you substitute this, all these conditions, that becomes 0, because T4 new temperatures are 0 and 0. T3, T4 and A. They are 0, 60 actually, they are changed to 0, 0. So T4, T3 is 0, this becomes 0, T3 is 0, so USX is becomes 0. So U of xt is US plus UTR xt, but US is 0, so UXT is simply UTR xt, which is same as sigma an sin n pi x by l e power minus pi square n square c square t by l square. So since T3, T4 and 0, an becomes, where is that? An, this one. Yes. T1, T3, T4. These things are zeros. Okay. So only thing is T3 will be there. So that minus 60. T3 is minus 60 power minus 1 power n. That becomes 120 by pi sigma n from 1 to infinity minus 1 power n plus 1 by n into sin n by x e power minus pi square n square c square by t. When both the ends are insulated, find the temperature in a thin metal rod of length L with both the ends insulated, no passage of heat through ends, and with initial temperature sin pi x by L. So the dou u by dou t is equal to c square dou square u by dou x square, subject to the condition dou x by dou x, because that means these two things are also insulated now. So dou u by dou x at x is equal to 0 is 0, dou u by dou x, that means this temperature is not there, the flow is not there. U of x0 is sin pi x by L. So if you put these things here, this is the final solution you get by A naught, calculate A naught and En. These are some of the applications of partial differential equations. Now we'll go to the whole question papers on differential equations. Ordinary differential equations also we have discussed some problems, but we have not discussed old questions. Questions asked on the previous GATE examinations. Let us see GATE problems, various previous papers and ordinary and partial differential equations. We will solve them first, then we will go to the next topic, numerical methods. So the first question here is dy by dx is equal to y minus 20 and y at x is equal to 0 is 40. The value of y at x is equal to 2 is. So this is variable separable method. So dy by y minus 20 is equal to dx. So log y minus 20 is equal to x cx, or y is equal to 20 plus e power cx. So initial condition is given, y at 0 is 40, then you have to calculate this solution at x is equal to 2. So this is a first get the solution by variable separable. Variable separable means terms of y dy and x dx are separated. So this becomes dy by y minus 20 is equal to dx. Then integrate log y minus 20 is equal to x, constant times x, or y minus 20 is equal to e power cx, or y is equal to 20 plus e power cx. Now when x is equal to 0, e power cx becomes 1. Okay. So then calculate the value of c. From using c, get the value of this. That's how we have to do this. The ordinary differential equation d square u by dx square minus 2x square u plus sin x is equal to 0. Is a linear and homogeneous equation. Is not a homogeneous equation. Okay. Non-linear homogeneous, non-linear non-homogeneous, and linear and non-homogeneous. We say that the equation is linear if it is linear in dependent variable. We don't worry about independent variable. Equation is said to be a linear equation if it is linear in dependent variable. What is the dependent variable here? U. Yes, it is linear because the power of u is, degree of u is 1 here. This is also degree of d square u by dx square is 1, and we don't have product like u into du by dx and u into d square u by dx square like that. So it is a linear equation in u. Is it homogeneous? No, it is non-homogeneous. So it is not linear, non-linear homogeneous kadu. So non-linear non-homogeneous and linear non-homogeneous. It's a linear equation but non-homogeneous because sin x term is independent of u here. Why it becomes non-homogeneous? If you expand this d square u by dx square minus 2x square u is equal to sin x. This term q of x is there. F of dy is equal to q of x. We have discussed no that q of x is minus sin x here. So it is non-homogeneous. An ordinary differential equation is given by 6d square y by dx square plus dy by dx minus y is equal to 0. What are the roots of this? So this is the homogeneous differential equation. We don't have particular integral. For these problems we have only complementary functions. For the complementary functions, what you have to do? You have to construct the auxiliary equation. What is the auxiliary equation? 6m square plus m minus y. 6m square plus m minus 1 is equal to 0. Okay. So if you take the factors are m square plus m by 6 minus 1 by 6 is equal to 0. Okay. So find the factors. Let us see if alpha and beta are the factors. The solution becomes e power c1 e power alpha x plus c2 e power beta x. Right? So that's how we get this solution. For the ordinary differential equation d square x by dt square minus 54 dx by dt plus 6x is equal to 0 with the initial condition. So while doing problems, we are thinking that the problems are very lengthy, but don't be impression. Equal problems, problems with equal measure and magnitude are being asked in the examination. See this problem. You have to find the complementary function first. Then you have to use the initial conditions and boundary conditions. Substitute. You have to get the solution. So what we have discussed is not too lengthy. So first 50 d square x by dt square minus 54 dx by dt plus 6x is equal to 0. This is a homogeneous equation in x. The solution becomes of that you have to consider the other equation m square minus 54m plus 6 is equal to 0. So from that it should be, I think somewhere some mistake, it should be 5. It should be 5. It's not 54. d square dx by dt square means 5 dx by dt plus 6x is equal to 0. Then you will get the complementary function. Then it involves c1 and c2 too, because second order equation, the complementary function will have 2 arbitrary constants. If you solve those 2 arbitrary constants using these conditions, you will get the solution. So this is not 54, this is minus 5 only. The general solution of d square by dx square minus 6 dy by dx plus 9y is equal to 0. The auxiliary equation is m square minus 6m plus 9 is equal to 0. It is nothing but m minus 3 whole square. M minus 3 whole square. So the roots are 3 comma 3. So the solution becomes repeated roots. So c1x plus c1 plus c2x into e power 3x. That is the solution. Consider the initial value problem below. The value of y at x is equal to ln2. You have to calculate the value of x at ln2. Okay. So far this is the equation now. dy by dx is equal to 2x minus y. A simple linear differential equation. So the solution is the integrating factor is e power integral p dx. So that means e power x, because this is dy by dx plus y is equal to 2x. Coefficient of y is, that is what we call px. So then integral e power integral p dx, that is integrating factor, is equal to e power integral dx e power x. So the solution is y into integrating factor e power x, that is e power x. Y into e power x is equal to e power x into integral q of x into e power minus p integral p dx. So this is direct solution. So then once you get the solution like this, this is solution. You put this condition y at 0 is 1, put x is equal to 0, e power 0 is 1, so y. This becomes 2x e power x becomes 0, minus 2 plus c. This becomes 0, this becomes minus 2 plus c. So c minus 2 is equal to y at 0. Y at 0 is 1. So c minus 2 is equal to 1. So c becomes 3. So the solution becomes e power x y is equal to 2x e power x minus 2 e power x plus c. And what is asked? What is the value of y? X is equal to ln2. ln2. So if you put x is equal to ln2, e power ln2 is 2. That means 2y is equal to 2x into 2 minus 4. So if you calculate this, this is what we get. Finally, 0.xx63 is your answer. The equation of motion of spring mass damping system is given by d square x by dt square plus 3 dx by dt plus 9x is equal to 10 sine 5t. Damping factor for the system is, so the standard equation is mx double dash is equal to cx dot plus kx. So m is equal to, here if you compare this equation with the standard equation, m becomes 1, c is equal to 3 and k is equal to 9. So damping factor is given by c by cc. So all this calculation if you did becomes 0.5. The following partial differential equation C is defined for u of xy. Dou u by dou y is equal to dou square u by dou x square. The set of auxiliary conditions necessary to solve the equation uniquely is, we have been dealing with this equation, one-dimensional heat equation. Only the thing is, in place of t, he has given y. But for that, it is a one-dimensional, looks like a one-dimensional heat equation. And what are the different conditions we are studying to solve one-dimensional heat equation? Metal rod, heat at this point, heat at this point. They are the boundary conditions. And then what we are studying? One initial condition, u of x0. U of x0, x is equal to 0, u of x is equal to L, and u of x when t is equal to 0. These are the three conditions where we require to solve equation of the form. So one initial condition and two boundary conditions are required. The option is A. Next, consider the ordinary differential equation x square d square y dx square minus 2x divided by dx plus 2x is equal to 0. Given the values of y1 is equal to 0, y2 is equal to 2. Value of y3, yes. How do you solve this equation? We have to, this is called Cauchy's equation. Put e power x is equal to t. E power x is equal to t. Then if you solve that, we get the solution. Then x square d square double dash is equal to d square y d by dt, and x dv by dx is equal to dy. So substitute those things here. That will be converted into a constant coefficient equation. So an ordinary differential equation is given by dy by dx into x ln x is equal to y. The solution for the equation is simply this is a variable separable equation. Dy by y is equal to dx by x log x. So log y is equal to log of log x, I think we get log x. Variable separable, simple variable separable equation. The solution of the arbitrary ordinary differential equation dy by dx plus 3y is equal to 1 subject to initial condition. It is a linear equation, or you can solve this equation using variable separable also. Excuse me. Simple variable separable equation or linear equation also you can solve. Families of curves is a very nice problem. Very nice problem. The family of curves represented by the solution of the equation dy by dx is equal to minus x by y whole power n, where n is equal to minus 1 and 1 or respectively. You need to have the understanding of differential equation and the geometry of the solutions also here. Say for example, n is equal to 1. dy by dx is equal to minus x by y. If you cross multiply y dy plus x dx is equal to 0. If you integrate, x square plus y square is equal to c square. What is x square plus y square is equal to c square? Circles. So what are the two different options we have? A, B and C, all three are possible. Now, if n is equal to minus 1, what happens? This will be inverse, x by y whole power minus 1, that becomes y by x. Then if you cross multiply, x dy plus y dx is equal to 0. What do you mean by x dy plus y dx? It is derivative of x into y, UV formula. d of xy is equal to x dy plus y dx. So d of xy is equal to 0 or xy is equal to constant. What is xy is equal to constant? Hyperbola. So when n is equal to 1, we are getting circles. For n is equal to minus 4, we are getting hyperbola. So the answer is, those represent, for n is equal to minus 1 and 1, they represent circles and hyperbola. Answer is 3. C. Answer the homogeneous differential equation x square d square by dx square minus 3x dy by dx plus 3y is equal to 0. For x greater than 0, x is positive. Y of x is as a general solution. Given that y at 1 is equal to 1 and y of 2 is equal to 14, find the value of y at 1.5. So that means lengthier problem than any of the problems we have done in differential equation. What we have done is we have simply considered Cauchy equation, obtained the solution by putting x is equal to something, log t is equal to log x something, x is equal to e power t, something like that. Okay, but you have to get the solution, eliminate the constants and find a new value. So very long problem. We have to apply. Only thing is we don't have a qx here. That's the only advantage we have. Okay, so be careful with this. The equation dy by dx plus 7x square y is equal to 0. If y of 0 is equal to 3 by 7, the value of y of 1. So this is a linear equation. E power px is 7x square. So integrating factor is e power integral p dx 7x cube by 3. Okay. So y of 0 is equal to 3 by 7. So the right-handed 0. So the solution will be e power minus 7 by 3x square. X is equal to 0. Then y is equal to, that's all. Okay. Simply get C. The differential equation dy by dx plus 4y is equal to 5 is valid in the domain 0 less than or equal to x less than or equal to 1 with y at 0 is equal to 2.25. The solution of the differential equation is, so again, this is a linear, this can be considered as a variable separable equation because dy by 4y minus 5, this is 5 minus 4y, right? dy by 5 minus 4y is equal to dx. You simply solve this equation, 1 by 4 log 5 minus 1 by minus 4 log 5 minus 4y is equal to x plus constant. So that's how you can solve this equation. Otherwise you can solve it as a linear equation also. The differential equation is given by so on and so forth. Yes. So again this is a Cauchy equation. I told you at the end you have to substitute again t is equal to log x. Otherwise you will go wrong. Okay. T is equal to log x, you have to substitute it at the end. So this is a Cauchy differential equation. This can be converted into variable coefficient. This can be converted into differential equation with constant coefficients by taking t is equal to log x or x is equal to e power t. Then that will be converted into differential equation with constant coefficients. Right hand side is 4. Then get the solution. At the end again if you have to put t is equal to log x. So if you solve this problem and then C1, C2 you get like this. So this becomes x square d square by dx square d square y by dt square minus 2 into dy by dt plus 2 is equal to 4. That's how we get this. The relative decline rate of oil is given by 1 by Q dQ by dt is equal to minus A into Q power B, where Q is the oil production rate. A is greater than 0 is the definite rate and B is constant. A and B are constants. The equation gives harmonic decline curve when B is. When does this B becomes? It becomes a harmonic decline curve. So that's a very nice question. Okay. So harmonic. When do you have harmonic equation? When do we have harmonic? Harmonic equation is d square y by dx square plus a square y is equal to 0. Okay. So dq by dt is equal to minus a into qb. Q power b. So if we multiply throughout, minus a into q power b plus 1. If it is b is equal to 1, dq by dt is equal to minus aq square. Okay, q into q. Then once again, if you differentiate this becomes 2a into q. So that's we get harmonic equation. The general solution of the differential equation. So get this complementary function for this and then evaluate C1, C2. You get C1, C2 arbitrary constant. Okay. Get the auxiliary equation, roots of the auxiliary equation, substitute, and then write the complementary function. Because the auxiliary equation is m square minus 2m plus 1 is equal to 0, or m is equal to plus 1 are the roots, then solution becomes y is equal to c1x e power x. Repeated roots, no? Repeated roots, yes, D. The partial differential equation is, what is the equation here? Let us say if dou square u by dou a square is not there, what is the equation? Then this is use dou square u by dou t square is equal to c square dou square u by dou x square. This equation is one dimensional wave equation. If we add a similar term along y direction, then it becomes a two-dimensional wave equation. The solution up to 3 decimals at x is equal to 1 of the differential equation d square over dx square plus 2 divided by dx plus y is equal to 0, subject to the condition y at 0 and dy by y dash at 0 is minus 1. See, we are getting very long lengthier questions here. There is no doubt about it. So again, if we consider auxiliary equation m plus 1 whole square is equal to 0, or m is equal to minus 1, your complementary function becomes c1x plus c2 e power minus x. Okay, so substitute the constants. So what happens is c1 becomes 1. Then y derivative to find out and put y is equal to 0, you'll get c2 also. The solution of the equation x dv by dx plus y is equal to 0 passing through 1, 1. Simple variable separable method. This is xy is equal to constant. So c becomes constant. So similarly, simply you get c is equal to, so xy is equal to 1, so y becomes 1 by x. So the answer is x power minus 1. Consider the following two equations, simultaneous equations. The above set of equations is represented by, so dx by dt, what is dx by dt? This is d square over dt. Dx by dt becomes d square over dt square. Substitute that here. So d square over dt square, x is dy by dt plus y. So d square y by dt square plus dy by dt plus y is equal to 0. C. A curve passes through the point x1, y0 and satisfies the differential equation, so on and so forth. Okay, the equation that describes the curve is basics of method of inspection we have discussed now from that. The position of a particle is given by d square by dt square is equal to minus 4 dy by dt minus 4 by say constant coefficients equation. The initial conditions are given. The position of particle at t is equal to pi. First find the solution of this and put these conditions. Evaluate C1, C2 existing. Then get the solution at t is equal to pi. Consider a system governed by the equation dx1 by is equal to so and so, dx2 so and so, The initial conditions are such that x1 less than x10 less than x20 less than infinity. Let x1f is equal to limit t goes to infinity, x1t and x2 so on and so forth. So you have to solve this. This is a standard result. You have to go back to the solutions of simultaneous differential equations for this. I think in 2020 syllabus, the simultaneous equations are not there in the syllabus also. Why is the solution of the differential equations? So what is the value at y at minus 1? It is variable separable equation. So y cubed is y power 4 plus x power 4 by 4 or y power 4 plus x power 4 is equal to 0. Okay. Given the ordinary differential equation d square by dx square plus dy by dx plus minus 6y is equal to 0, with y0 is 0 and dy by dx at 0 is 1, the value of 1 corrected to. In all the problems, they are asking the complementary functions and are asking you to evaluate the constants using some conditions. So be very thorough with the finding of complementary functions using some conditions y at 0, y at 1, y dash 0, and practice how to evaluate the constants using the conditions given. Okay, most of the problems are of that sort. Which of the following is integrating factor for the differential equation? So we have seen Bernoulli's equation, reducible to Bernoulli's equation. First make this independent of a function. Then what happens? dy by dx plus y secant square x is equal to secant x. Secant square x is px here. So what is integral e power integral p dx? E power integral secant square. Secant square is tan x. So e power tan x. So these things, just by looking at just small 1 or 2 steps, you can do it on your own. Need not even put on paper, but you can solve it. The solution at x is equal to 1, t is equal to 1 of the partial differential equation is, subject to the initial condition v0 is 3x and dou u by dou t at 0 is 3 is, so many things is, lot of things are given here. So try to calculate this. Consider a function like this which depends on function of x and t. The partial differential equation is known as, what is this equation? Heat equation. The solution of this very simple equation, variable separable. Second order differential equation, the particular solution of, yes, we have done some problems on these polynomial functions. What would you find a solutions of polynomial function? Particularly is 1 by d square minus 4d plus 3 operated on 2t minus 3t square. We have to write this as 1 by 1 plus r minus 5d or 1 plus r minus 5d whole inverse operated on this 2t minus 3t square. So for the initial value problem, dx by dt is equal to sin t, x0 is 0, the value of x at pi by 3. You can do it easily. Find the solution first, integrate, dx is sin t dt, or integral sin t dt equal minus cos t plus c. So c becomes 1. So 1 minus cos pi 3, that is the answer. Which one of the following is general solution of the first order differential equation? So to reduce this to variable separable method, put x plus y minus 1 is equal to some t. Put t is equal to x plus y minus 1. So dt is 1 plus y dash. So substitute here, this becomes variable separable equation. Then easily you get the solution one of these alternatives. The general solution of the differential equation y double dash plus 2 dv by 2y dash minus 5y is equal to 0. So for that we have to calculate the roots of the auxiliary equation. Auxiliary equation is m square plus 2m minus 5 is equal to 0. So if you calculate these roots, you don't get exactly the roots will get in something like minus 1 plus or minus root 2. I think we have done this problem, I remember. The roots of the equation should not pass by root of the equation, roots of the auxiliary equation. So dq by dx cube must, so auxiliary equation is m cube minus 6m square plus 11m minus 6 is equal to 0. So first get the roots and solve the problem. So I give you a trick here. The polynomial is m cube minus 6m square plus 11m minus 6 is equal to 0. If you go back to the fundamentals of polynomial, roots of polynomial, the product of the roots is equal to the minus of constant by an by a naught. So this is minus 6, minus of minus 6 plus 6 by 1. So the product should be 6. If you see the constant, its product is 2, it is 6, it is 12, it is 8. So obviously by looking at this, you can say this is the answer. The differential equation 2x by dx plus 1 plus x square dy is equal to 0, in which x is independent variable and y is dependent variable, is an ordinary differential equation of first order, second order, a first order non-linear differential equation, exact differential equation, a partial, it's not a partial differential equation, it's not a second order differential equation. So first a and d are eliminated. Is a first order non-linear differential equation? No, it is not non-linear. Why it is non-linear? We say that a differential equation is a non-linear differential equation if the degree of the dependent variable or any of the independent derivatives of the dependent variable are more than 1, degrees must be greater than 1. It's not so. So it is the option B is also is wrong. So the only thing is it is exact differential equation. You have to check it. Is m dx plus n dy. So dou m by dou y is 2x and dou n by dou x is 2x. Since both are equal, it's a first order exact differential equation. Consider the following boundary value problem. So partial differential equation 3 dou square 5 by dou x square plus b dou square 5 by dou x dou y plus 3 dou square 5 by dou y square plus 4 5 is equal to 0. For this equation to be classified, the value of b square must be. For parabolic equation, b square minus 4ac is equal to 0. B square minus 4ac, so b square minus 4ac is a is 3, c is 3, 9, 4ac is 36. So b square must be equal to 36. So b square will be 35.9 to 36.1. Then this becomes a parabolic equation. This type of questions we are getting in classification of series. So with this, you can say successfully we have finished off partial differential equations, and that is the end of ordinary and partial differential equations also with the gate questions. Now we will shift our focus completely different concept. We have been dealing with calculus, derivatives, partial differentiation, the integration, multiple integrals, partial differential equations, so much of heavy stuff till now. Now completely change our attention to numerical methods. I hope you all enjoy doing numerical problems in numerical methods. If you have a calculator, then you can enjoy these numerical methods. That is there we have here. It's not. So what we have here is the next topic, numerical methods. Yeah. So in numerical methods, most of the 90% of the contents are like this: numerical solutions of linear and nonlinear algebraic equations, integration and trapezoidal and Simpson's rules, and single and multi-step methods for a numerical solution of differential equations. This is the brief syllabus of numerical methods. So, but still in the syllabus of GATE, The methods are not mentioned. So numerical solutions of linear and non-algebraic equations, there are so many methods for solutions of non-linear equations. And there are so many other methods for solutions of linear equations. Linear equations means simultaneous equations. So we have Gauss elimination, Gauss Jordan methods. Because we have already discussed these methods, Gauss elimination, Gauss Jordan methods in linear algebra, I am not throwing a light on that. We will be going through only iterative methods of finding system of linear equations after non-linear algebraic equations. First we study these linear numerical solutions of algebraic and transcendental equations. We know what is an algebraic equation. If you want to find the roots of ax square plus bx plus c is equal to 0, a quadratic equation, then it's an algebraic equation. If you want to find the root of x power 6 is equal to 25, it's an algebraic equation. If you want to find the root of x plus 1 by x square plus some other thing is equal to, then the root of that is an algebraic equation. They are all algebraic in nature. Transcendental have a different meaning, but simply saying that for layman's understanding, the function involves exponential, logarithmic, trigonometric, hyperbolic and algebraic functions, then it is a transcendental equation. So first we will now deal with algebraic solutions of, numerical solutions of algebraic and transcendental equations. So if I simply give you a second degree equation polynomial ax square plus bx plus c, you can get the roots easily, minus b plus r minus square root of b square minus 4ac by 2e. And if I give a cubic polynomial and if you know one of the roots, let us say x is equal to alpha, then by so many other methods, simply basically synthetic division, you can get the roots. They are all called analytical methods and exact methods. We know that analytical methods and exact methods, they give exact roots, best roots, but they often fail in drawing inferences from a given data in finding roots of transcendental equations. As far as the algebraic equations are concerned, they do an excellent job, appreciated, but coming to the transcendental equations, you cannot say the roots just like that by any exact method or analytical method. We need the help of numerical methods. Therefore, the purpose of numerical methods is to provide methods to solve such problems which are not possible to solve using analytical methods. The value of alpha, what is the root of a function? Let us say, if you have a function f of x is equal to 0, equation f of x is equal to 0, then we want to find the root. Then what is a root? The value of alpha such that f of alpha is equal to 0 is called a root of f of x is equal to 0. Geometrically, it means that the value of x for which the graph y is equal to f of x crosses x-axis. X is independent variable. Let us say y is equal to f of x is the graph, and we are saying fx is equal to 0. That means y is becoming 0. When y becomes 0, what does it mean? The graph must cut the x-axis. Okay, so geometrical sense, root is nothing but, root of an equation fx is equal to 0 is nothing but the point at which the function or the graph of the function crosses the x-axis. That is what we mean by root geometrically. Let us see. So this is the function y is equal to fx or fx, and this fx becomes 0 at this point, alpha comma 0. Because this point is on x-axis, whenever this curve crosses this x-axis at this alpha, at this point the function becomes 0. That means at this point f of x becomes 0. So there will be this x, at this point it becomes f of alpha is 0, alpha is a root. Here y is equal to f of x crosses x-axis at alpha comma 0. That means at x is equal to alpha, f of alpha, the function value becomes 0. So f alpha is 0, and then hence alpha is root of f of x is equal to 0. Then comes the basis for all the numerical methods. This is the basic principle behind all the numerical methods. That is intermediate value property. Intermediate value property. If f of x is continuous function in closed interval AB and f of a and f of b have opposite signs, okay, or you can say when they are opposite signs, the product of these two numbers becomes negative. F of a and f of b is less than 0. Then fx is equal to 0 has at least one root in open AB. This is what we call intermediate value theorem. So see here, f of a, this is f of b. This is f of a, this is f of b. Okay. I have marked current is. So this is f of a. This is f of a and this is f of b. This is in the positive y-axis, upper half of the plane. That means y is positive. Here f of b, the curve is below x-axis. That means it is in the fourth quadrant in which y is negative. So f of a is positive and f of b is negative. And the function is connecting these 2 points. We have a line here, 1 point here, 1 point here. If we want to go from this point to this point, you have to cut through this axis only. Otherwise, you cannot go. So when it crosses the x-axis, it means that there is a root. So this property is a common sense, but it's a very wonderful property, mathematically formulated property, well articulated property. So this is the basis for all the numerical methods. If f of x is a continuous function in closed AB and f of a, f of b have opposite signs, then fx is equal to 0 has at least one root in open AB. So another important point that we require is if alpha plus I beta is a root of f of x, in complex numbers we know that alpha plus I beta is a root, then alpha minus I beta is also a root of the polynomial. As a consequence of that, say for example, if you take a third degree polynomial, okay, you have, let us say, third degree polynomial, then how many roots we have? 3 roots. Then can you have 2 different complex numbers as roots? No. So say for example, alpha 1 plus I beta is a root, then obviously alpha minus I beta 1 is also a root. How many roots are completed? 2 roots are there. The third one, it cannot be a complex number. It must be a real number. Why? If it is a complex number, its conjugate also must be a root, but we are saying we have 3 roots. Though we don't have room for the 4th root. So the third root must be a real number. So if alpha 1, alpha 2, alpha n be the roots of a naught x power n plus a1 x power n minus 1, so on and so forth, an is equal to 0, then there are some basic properties. And if you know these things, you can solve so many problems easily. We have seen the roots of the auxiliary equation. I said the product of the roots is equal to minus of 1 power n by a naught. We have solved this problem in differential equations. It has given the possible values of the roots of auxiliary equation. What are the roots of the differential equation? So if you know these properties, you can straight away answer this problem. See, if the polynomial is a naught x power n plus a1 x power n minus 1, so on and so forth, a n minus 1 x plus a n is equal to 0, then sum of the roots is minus a1 by a naught. Sum of the roots is minus a1 by a naught. And the product of the roots is minus 1 power n into a n by a naught. If you know these things, so many problems you can solve easily. Then solve the equation x cube minus 7x square plus 36 is equal to 0, given that one root is double the other. One root is double the other. Then people started doing the problem. First find one root, then go for synthetic division, and it takes long time. So let alpha, beta, gamma be the roots, and beta is equal to alpha because one root is double the other. We know that sum of the roots is minus a1 by a0. Minus a1 is minus 7. So minus of minus 7, 7 by a0 is 1. So alpha plus beta plus gamma is equal to 7. But beta is 2 alpha. So alpha into 2 alpha. This becomes beta is 2 alpha. Kada? So 2 alpha plus alpha, 3 alpha plus gamma is equal to 7. And the product is alpha into beta, that is 2 alpha, into gamma is equal to minus 1 power n an by a0. An by a0 is 36 by 1, 36. Minus 1 power n is degree of polynomial 3. So minus 1 power 3 is minus 1. So 2 alpha square is minus 36. Or alpha square r is equal to minus 18. So from this, if you solve these two equations, you get alpha is equal to 3 and r is equal to 2. So beta becomes 2 into alpha, that is 6. You know the properties, you can solve the polynomials also very easily. This is how we use those principles here. Then we deal with iterative methods. Iterative methods is the backbone of numerical methods. Okay. So then when do we say method is iterative method? Iterative means always start with initial approximation of the root. Initial approximation of the root. Sometimes we directly take the initial approximation of the root by a real number. Sometimes we take two numbers and we assume that the root lies between these two values. So the iteration of intervals. So either way, this is an iterative method. The approximation is successively improved by iteration by iteration. So first we start with initial approximation, then we refine it, we get next value. Again we refine it, we get next value. Like this, but after finite number of steps, we say that the final value that we get is the exact root. So these are called iteration. Iteration means refinement of the value. Each step we get a new iteration, and then step by step, we get the exact root. The process stops when the desired accuracy is achieved. So you want the final approximation to be very close to the exact root. How close it is, that is called error. So you need to have that accuracy level. So when the process reaches that desired accuracy, you stop the process. Based on the number of initial approximations required, they are classified as bracketing methods and open-end methods. I said now, sometimes we find the approximation of a root by exact number. Yes, the root is so 0, I assume that approximation is 1. And then from 1 I gradually go on this process and reach 0. Only I approximate the root only. Sometimes I assume that such methods are called open-end methods. Only one initial approximation. Sometimes what happens, the root lies between 0 and 1, A and B. Or else let us say 0 and 1. Then we refine the interval and we say that the root lies between 0 and 0.5. So what is done here? The interval is refined, interval is reduced. After again 0 to 0.5 becomes 1 by 4 to 1 by 2. Then 1 by 4 to 1 by 8. Okay. So interval is reduced. After finite number of steps, the interval becomes very, very, very small, and sure that the root lies in that interval. That is refinement of the interval. So those methods are because both the ends we have A and B. It's a bracket method. They are called bracketed methods. In bracketing methods, we discuss graphical methods, bisection methods, method of false position, etc. Basic methods. And open-end methods, we study secant method, iteration methods, Newton-Raphson, etc. etc. So we start with the brackets method, bisection method. Then what is bisection method? In this method, we apply intermediate value property repeatedly. What is intermediate value property? If f of x is a continuous function in a closed interval AB, such that f of a and f of b have opposite signs, then there exists a point at C in open interval AB at which this f of c becomes 0. The root lies between a and b. Let a and b the initial approximation such that f of a. What do we do in secant method, bisection method? First we select two numbers a and b. That will be called initial approximations. The selection is such that the function values at the end points, the 2 points a and b, have opposite signs. If one is positive, other must be negative. If this is negative, this must be positive. So that the product is always a negative sign. F of a and f of b is less than 0. The root lies in, whenever this happens, the root lies in the interval AB. So the root now lies between, anywhere in between a and b. So where? We don't know. So what we do is, for the next approximation, we off the interval. That means we consider a, b, middle point is a plus b by 2. We consider a and a plus b by 2. The first approximation x1 is a plus b by 2 and find f of x1. Okay. If f of x1 is 0, then x1 is the root. Your job is done. Otherwise, the root lies between either a to x1 or x1 to b. Compulsory, must. Why? Root is between a and b. Either in this part or in this part it must. Then which part do you take? We know the sign of f of a. You know the sign of f of b. Let us say f of a is less than 0 and f of x1 is also less than 0. Then root cannot be in this interval by intermediate value property. If f of a is less than 0, f of b is positive and f of x1 is negative. Then the root lies in between. So that comparison, the comparison of sign is done at every step. That is the backbone, this bottom line of this bisection method. At each and every step, we compare the sign of the function at the new approximation. If not, the rule lies between a to x1 or x1 to b, depending on f of a into f of x1 less than 0 or f of x1 into f of b less than 0. Again, of the interval x2 is a plus x1 by 2 or x1 plus b by 2. Find f of x2. Again, compare f of x2 with f of x1, a and b. Then the process goes on. Repeat the steps 3 to 5 till xn minus 1 goes to 0. We have to repeat the process till the new approximation. We are getting x1, x2, x3. The difference between the approximation goes to almost or two successive approximation must be very close to one another. Then we say that we stop the process. If xn goes to alpha as n increases, then alpha is the root of f of x is equal to 0. So that means this is a and this is b. A f of a, b f of a, they have opposite signs. We are considering the midpoint of this. Find f1. Okay, this is the upper half of x plane. So f1 is positive and f of a is negative. f1 is positive, f of b is positive. The root cannot be here. This is positive, this is negative. So the line join, the curve join these 2 points must pass through x-axis. So the root will be in between. So then again take a midpoint of these two things called x2. Find f2. Where is f2? Again negative. This is negative. So this is also negative. Okay. So the root lies between. So the process goes on like this. Okay. This is secant method. The rate of convergence. The rate of convergence plays a very important role. That defines the efficiency of a method. Sometimes the methods are very simple, but rate of convergence is very slow. Sometimes methods are a bit difficult, but convergence is very fast. So that depends on our requirement. Which one do we choose? Here the error decreases with each step by a factor 1 by 2. That is, error at n plus 1 stage is error at n stage by 2. So convergence is linear. It's a linear convergence. It takes a long time for the approximations to converge to a unique limit. So what are the merits and demerits? So these are all the questions that we are getting in theoretical aspect. Okay. So be thorough with these points. I have given just like bullets, right? I am not going to the proofs or any other study. Just I am giving a proof. Bullets. So say for example in bisection method, the convergence rate is quadratic or linear, cubic or 0 degree. So it's simply linear. So otherwise, if En is the error in bisection method, then En plus 1 is equal to En by 2, En by 3, 2E1, En square. So En by 2. These type of bullet questions you have to answer quickly. The short answer questions, very simple things. Then what are the merits and demerits of bisection method? First thing is very easy. Very easy. Compare the signs, go for the next midpoint, again compare the signs, goes on. It's very simple. 2. Method always converges. Because the root is between A and B, it is sure that we have a root between A and B. Okay. So it's sure to converge to a root, but very slowly. We take convergence rate, linear convergence of degree 1. Needs 2 starting values. That is one more thing. Here, A, B, we are considering 2 points, 2 approximations that you have to identify. And one more very important thing is, after n iterations, what happens? Actually, the initial interval is, length of the interval is B minus A. After each step, what happens? The interval becomes off. First we are taking A, and x1 is A plus B by 2, middle point we are taking. That means what is the length of the interval? It's off. First interval is B, let us 1. The second is, it is 0.5. So at each step, the length of the interval becomes half of the actual interval. Second step, another half. So after m interval iterations, what happens? This interval becomes B minus A by 2 over m. And if delta is the accuracy required, the most important thing in bisection method is, say for example, if you define the accuracy required, if you fix yes, I want 10 power minus 5 accuracy, let us say that is 10 power minus 5. Then how many steps you have to do? And how many steps are required to get that accuracy? You can calculate that because of this. So if you take logarithms both sides, m is greater than ln b minus a by ln 2. Okay. So log of b minus a, if you take that by ln 2, that gives the number, minimum number of iterations that you require. That is a very important aspect of bisection method. For a given accuracy, the number of iterations can be calculated. So that's about bisection method. Let us see a couple of problems on that. Find the root of x cube minus 4x minus 9 is equal to 0, corrected to 3 decimal point. You call this f of x is equal to x cube minus 4x minus 9. Clearly, we put 0. First, we have to find a and b such that f of a into f of b is less than 0. So, if we put x is equal to 0, this becomes minus 9 is less than 0. See the 1 point. Okay. We put x is equal to 1, 1 minus 4 minus 9, still negative. No problem. No, we don't require that because f of 0 is already negative. If you take x is equal to 2, 8 minus 8, 0 minus 9, still negative. So f of 3, if you take 3 cube is 27, minus 9, 18, minus 12, 6. So f of 3 is positive. So f of 0 is negative, f of 3 is positive, they are opposite sides. So root lies in the interval 0, 3. So what I take? First approximation is midpoint of this interval, x1 is 0 plus 3 by 2, 1.5. Calculate f of x1 is less than 0. Then f of x1 is less than 0, f of 0 is less than 0. Less than 0. There is no point in having considering this. So we don't require this interval. Now x1 is 1.5 is less than 0, f of 3 is greater than 0. So the rule lies between x1 and x3. So x2 is equal to x1 plus 3 by 2, that is 1.5 plus 3 by 2 2.25, and calculate the value of f at x2. It is also less than 0. So fx2 less than 0 and f3 greater than 0. So root lies between x2 and x3. What is x2? 2.25 and 3. Again take midpoint 2.625. Find f of x3 minus negative value. Okay. This is the interval. f of 3 is positive, f of x2 is negative, and f of x3 is again negative. Again, so root lies between x3 and 3. So x4 is x3 plus 3 by 2. So 2.8125. So it is taking a long time to go to the root because linear. So f of x4 is positive. So f of 3 is positive, f of x4 is positive, f of x3 is negative. So the root must lie between x3 and x4. So x3 is 2.625, x4 is 2.8125. The midpoint of that 2.71875. So find f of x5 is greater than 0. So f of x4 greater than 0, f of x5 greater than 0, but f of x3 is negative. So the root lies between x3 and x5. So let us say x is equal to x3 plus x5 by 2. It comes out to be 2.61875, and f of x6 is less than 0 again. So f of x6 less than 0, f of x5 greater than 0, root lies between x5 and x6. Core x7 is 2.6953 and f is minus 3. So go on like this. Yes, x6 is 2.67, x7 is 2.69. Almost like 10 power minus 2 accuracy we are getting. If you still go further, we arrive at x is equal to 2.70. See, this is a lengthy process. That's what we said in the merits and demerits. It's very easy, but method converges very slowly. So it needs another 2, 3 or 4 iterations. That means you have to go till x power 10 to get the solution. Okay, very in accurate, at least 10 power minus 2, 10 power minus 3 accuracy if you want. You have to go on the 2 to 3 iterations. Otherwise, f of 2 is negative, f of 3 is positive. You start with interval 2, 3, then you can get at a better rate. Okay, f of 3 greater than 0, f of 2 is less than 0. You can start in the interval 2, 3. That's also a good way. So this is how we do in bisection. Another problem, x log x base 10 is equal to 1.2. So this is f of x. Clearly f of 2 is negative value and f of 3 is positive value. So x alpha lies between 2 and 3. Let us say x1 is equal to 2.5. Find this is a, to avoid confusion, this is a better way. These are 2 and 3 are the first values, initial values we have taken. F2 it is less than 0, F3 it is greater than 0, and we are considering x1 is equal to 2.5 in between. So x1, f of x1 is negative. So I written negative here. Okay. So this is negative, this is negative. So the root lies between these two values. So x2 becomes the midpoint of this 2.5 and 3. There is 2.5. The function value is greater than 0. So x1 less than 0, x2 greater than 0. Again it is greater than 0. So this interval we need not consider. Leave it. So the root lies between these two, 2.5 and 2.75. Take the midpoint of that 2.625. Find f of x3. This is less than 0. This is less than 0. This is less than 0. So the root lies between these two. That means x3 and x2. The root lies between x3 2.625 and 2.75. So take the midpoint of that. X4 as 2.687. So x3 is 2.625. X4 is 2.687. Up to 2.6 we have some convergence. If you still go another 2 steps, we get excellent approximation, and it will coincide with 2.687 as the best approximation to the exact root. Find the real root of tan x is equal to x, fx is equal to tan x minus x is equal to 0, f of x1 is equal to positive, and f of x2 is less than 0. One beautiful thing here is we don't require the values of function. We require only the sign of the function values, positive or negative. We don't calculate the function values anywhere in the midpoint, this thing. Only the sign is important. We are not using the value of the function anywhere. So the root lies between 1 and 2. Let us say x1 is 1, x2 is 2. So x3 becomes 1.5. So f3 is positive. So like this, if you draw a diagram, a straight line, imagine a line like the real line, and then to avoid confusion, you can very quickly tuck, you can do the problem. So f3 is positive, f2 is f of x2 is negative, so the root lies between 2 and x2 and x3. That means 1.5 and 2. So go on like this. Under 3-4 iterations, you get alpha is equal to 1.578. This is bisection method. So next method is method of false positioning. With this method, I will stop. Method of false position, or this is also known as regular falsy method. Regular falsy method. Procedure is choose 2 points x0, x1 such that f of x0 into f of x1 less than 0. Again, the same intermediate value theorem. That property is we have to use at each and every step. We have to first choose the initial approximation x0, x1 such that f of x0 into f of x1 is less than 0. Connect the chord, say geometrically if you see this. So I have taken x0 here and f of x1 here. This is the above in the positive x-axis side and in the negative x-axis side. They have f0 and f1 have opposite signs. Next come to chord joining these 2 points x0, f0 and x1, f1. Because one is above x-axis and the one is below x-axis, if you join these 2 points, then it must cross x-axis somewhere. Consider that point. Consider the point. Okay. The chord joining these 2 points is given by y minus f0 is equal to f1 minus a point slope form of the straight line. Y minus f0 is equal to f1 minus f0 by x1 minus x0 into x minus x0. This is the equation, point slope form. But when this chord crosses x-axis at x2, what happens to y? Becomes 0. So when you put y is equal to 0, you will get that value of x at which this chord x crosses x-axis. So if you put y is equal to 0, that means that the point of intersection of the chord and x-axis be x2. That means this one x2 comma 0. So that x2 will be minus f0, y is 0, f1 minus f0 by x1 minus x2 into x2 minus x0. Or else if you multiply and if you take all the terms to the other side, x2 is equal to x0 minus x1 minus x0 by f1 minus f0 into f2. Now this f2, this is a point at x2. Now drop a perpendicular onto the curve. So this is the point. So this x0, f0 is above the initial line, x is equal to x-axis, and you have to identify where this point lies. Now this point here, this point is here. Can the root be in between these two? No, because both having negative values. This is negative value, this is positive value. So that means again the root lies between these two. Now join this chord like this, these 2 points. So again this chord touches this x-axis x3. Then again drop a perpendicular to the curve. If this point is again here, again the root lies in between these two. Cannot be here. So we repeat the process. So if f0, f2 less than 0, repeat the steps 2 and 3, we get x3. The procedure continued till desired accuracy is achieved. This is the geometry of that, and at each and every step you go on finding the new point using the chord and the point of intersection of the chord and x-axis. At each point the xn plus 1 is defined as xn plus 1 is equal to xn. Generalization of this is x2 is x0 minus x1 minus x0 by f1 minus f0 into f0. The generalization of this is xn plus 1 is equal to xn minus fn by f1 minus fn minus 1 f by x1 minus xn. Or else we use another formula, just we simplify that, xn minus 1 fn minus xn into fn minus 1 by fn minus 1 n from 1 to 3. These are also very standard. These 2 things are one and the same, just only thing is we have to Take LCM and simplify, that's all, nothing more than that. This is easy to remember. So what are the merits and demerits of this regular falsy method? It is not simple. Why is not simple? How many values we need? We need xn minus 1, xn, and the function value at fn minus 1, fn. If you know, if n minus 1 and f of n minus 1 and f of n minus 1 and f of xn are calculated, then only you can calculate next point. So it is not as simple as bisection method. It also converges definitely. Why? We are always considering the mean value property, intermediate value property. When the function is having opposite signs, it must have a root in between a and b. So sooner or later, the convergence is assured. So convergence definitely, but faster than the bisection method. Faster than the bisection method. Needs here also we need two starting values because we are using intermediate value property. Here also we need two starting values. That is the only thing that will show back, and then it is not relatively difficult computation. So find the real root of e power x sin x is equal to 1. Let us say f of x is equal to e power sin x minus 1 is equal to 0, and take x naught is equal to 0.5 and f of 0.5 is less than 0. F of 0.6 if we calculate is greater than 0. So root must be between 0.5 and 0.6. So x2 is equal to, if you apply this formula, x naught f1 minus x1 f0 by f1 minus f0. This is f1 minus f0. So we put these values here, we get 0.588, and then find the value of f at 0.588, that is called f2 is less than 0. So f1 is greater than 0, f2 is less than 0. F1 is x0 x1, this is f1, this is x, this is f0, this is f1. F1 greater than 0, f2 is less than 0. So the root lies between f1 and f2. Sorry, x1 and x2. So x3 is x2 f1 minus x1 f2 by f2 minus f1. If you calculate 0.5885. What is x2? 0.588. And what is x3? 0.5885. So almost all 10 power minus 3 accuracy. So if you find x3 minus x2, absolute value of x3 minus x2, 0.0005, 10 power minus 4 accuracy. So alpha is approximately equal to 0.588. Under problem, find the real root of log x is equal to cos x. Consider log x minus cos x is equal to 0. At x0 is equal to 1, f0 is equal to less than 0. At x1 is equal to 2, f1 is positive. So root lies between 1 and 2. So because f1, f2 is less than 0. So xt is x0 f1 minus x1 f0 by f1 minus f0. You substitute all the values that you have calculated here. This becomes x2 is 1.3275. So f2 is, we calculate f2, the function value at x2, that is f2, this is positive. At x0 is equal to 1, it is less than 0, and at x2, 1.3275. So the root lies between these 2 points. So for these 2 points, f0 and f2 greater than 0, x3 belongs to x0 and x2. So x0 f2 minus x2 f0 by f2 f0. f2 minus f0. You simplify those, substitute those values and simplify, you get 1.3037. And function value at 1.3037 is less than 0. f2 greater than 0 is what we got. f2 greater than 0 and f3 is less than 0. The root lies between x2 and x3. Let us say x4. Let that will be x2 f3 minus x3 f2 by f3 f2. f3 minus f2. We simplify that, 1.3214. We take the approximate value. See, because x3 is 1.3037, x4 becomes 1.3214. This step, you have to take this procedure further under 2-3 steps to see that the root converge, the approximations will converge to 1.3214. I have written the statement because to avoid time, we have to repeat the process repeatedly. You can practice that. X log x minus x plus log x minus 2, x0 is equal to 1. So f0 is less than 0. At x1 is equal to 2, it is greater than 0. So root lies between this, so xt belongs to 1, 2, xt will be x0 f1 minus x1 f0 by f1 minus f0, so it comes out to 1.7686. So and the value of function is less than 0, so sorry, greater than 0, and f0 is less than 0, so the root lies between f0, x0 and x2, so x3 belongs to this 1 and what is x2? 1.7686. So x3 will be x0 f2 minus x2 f0 by f2 minus f0, 1.75 x3. So f3 is greater than 0. So f of x3 is very close to 0. Almost all. F is almost all 0 at 10 power minus 3 of 0. So whenever the function is 0 or very close to 0, that value of x is called as root. So it is almost all, f3 is almost 10 power minus 8 accuracy to 0. Then you can take the root as 1.7563. That's what we mean by regular falsy method. So I'll stop today with this. Tomorrow we will see secant method, Newton-Raphson method, and then we'll go to algebraic equations, Gauss-Seidel method, and then numerical integration and numerical differential equations. Okay, bye for today.